A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. This morning in North Carolina, wheels are spinning. Determination is winning. A passion is now a thriving business, and it shows no signs of slowing down. How? The power of a conversation, like the one Clint Spiegel had with First Horizon Bank about starting a bike wheel manufacturing facility in Asheville. Now it's not just talk, it's rubber meets road. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Clint. First Horizon Bank, member FDIC.
This is SpaceTime, Series 26, Episode 60, for broadcast on the 19th of May, 2023. Coming up on SpaceTime, creating a black hole in a supercomputer on Earth, Rocket Lab launches NASA's new Storm Chaser satellites, and Virgin Galactic to resume flights to the edge of space next week. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have created a black hole on Earth using supercomputer simulations. The modelling provided an accurate recreation of the jet streaming out of a supermassive black hole. The research, reported in the Astrophysical Journal, will help scientists better understand how black holes affect and shape their host galaxies. All galaxies, including our own galaxy, the Milky Way, are thought to contain supermassive black holes at their centres. The one at the heart of the Milky Way, known as Sagittarius A star, is about 27,000 light-years away and around 3.4 million times the mass of our Sun. But these gravitational monsters can be millions to billions of times larger, some of them proving to be the most powerful engines in the known universe. The biggest, known as quasars, can be seen shining across the other side of the cosmos like beacons in the night, more than 13 billion light-years away. Understanding how they work and how they affect space and time is a major goal in astronomy. Now, a pair of scientists from NASA's Goddard Space Flight Center in Greenbelt, Maryland, have used the enormous computing power of NASA's Center for Climate Simulation Discover a supercomputer to explore a key aspect of black holes, the powerful superluminal jets produced by these behemoths as they feed on stars, planets, and other material. The authors ran hundreds of simulations involving black hole jets, which are also known as AGNs or active galactic nuclei, to see how they emerge from black holes and how they interact with the galaxies around them. The jets are generated as powerful beams of energetic particles, blasting into space perpendicular to the black hole's accretion disk and travelling at nearly the speed of light. The study's lead author, Ryan Tanner, says as these jets and winds flow out from the active galactic nuclei, they regulate the gas in the centre of the galaxy and affect things like star formation rates and how the gas mixes with the surrounding galactic environment. For their simulations, Tanner and co-author Kimberly Weaver focused on less studied low-luminosity jets and how they determine the evolution of their host galaxies. Observational evidence for jets and other AGN outflows first came from radio telescopes, and then later from NASA and European Space Agency X-ray telescopes. Over the past 30 to 40 years, astronomers including Weaver have pieced together an explanation of their origins by carefully connecting optical, radio, ultraviolet and X-ray observations. The high-luminosity jets are easy to find because they create massive structures that can be seen in radio observations. But the low-luminosity jets Tanner and Weaver are looking for are far more challenging to study observationally. Consequently, astronomers don't understand them nearly as well. In order to build their synthetic black hole, Tanner and Weaver started by designing a galaxy whose total mass is about the same as that of the Milky Way. For gas distribution and other AGN properties, they looked towards other spiral galaxies, such as NGC 1386, NGC 3079, and NGC 4945. Tanner then modified the Athena astrophysical hydrodynamics code in order to explore the impact of the jets and cosmic gas on each other across 26,000 light-years of space, about half the radius of the Milky Way. From the full set of 100 simulations, the author selected 19, which consumed some 800,000 core hours of supercomputer time. And these simulations uncovered two major properties of low-luminosity jets. Firstly, they discovered that they interact with their host galaxies much more than high-luminosity jets do. And secondly, they both affect and are affected by the interstellar medium in which they're travelling. And that leads to a greater variety of shapes and structures than high-luminosity jets. Weaver says the findings show how the jet impacts its galaxy and how it creates physical features in the interstellar medium such as shocks, which astronomers have observed for the past 30 years. Tanner says the results compare well with optical and X-ray observations. This report from NASA TV.
There are some problems in astrophysics that can't be solved on a normal computer. For this we use a supercomputer. My name is Ryan Tanner. I study active galactic nuclei and star formation and how they affect galaxies. I have been doing research and computer simulations of galactic outflows for a number of years now.
My name is Kim Weaver and I work at NASA. I've been looking at AGN for a very long time, and we just don't understand how the jets impact the galaxies in these low luminosity objects.
An AGN is where you have a supermassive black hole at the center of a galaxy, and occasionally there's gas or a star or something that gets too close to the supermassive black hole and it begins to get pulled in by gravity. But when it does that, it releases a huge amount of energy.
There are strong jets and weak jets. High-intensity AGN, the large jets, have been studied for a long time. We've seen, they're very obvious. You can see them on the sky. You see them bright in the radio emission. You see them bright in the optical.
The largest ones can get several million light years in size.
The low luminosity jets are much harder to find and often do not even leave their galaxies and are very compact.
We know some things about the AGN, but we don't know everything. It's like a big puzzle piece. We're doing a jigsaw puzzle and there's pieces that are missing, and there's some that we have fairly well put together, but others where we have no idea what's there. One of the major puzzle pieces that we're missing is how these low luminosity AGNs impact and determine the evolution of their host galaxies. For this problem, we have to use supercomputers. For my research, I use a code called Athena. It can do anything from planet formation, star formation, supernovas, and anything in between. And I did some modifications to it in order to tailor it to my exact problem that I have.
The process of watching this was impressive because, there's so much computation going in and there's so much focus going into this project, and the outcome is going to be something pretty spectacular, but it takes time. So Ryan came to me and said, I need a supercomputer, and I said, okay, what? Because I had never helped anybody get the supercomputer time. I've seen it, I've been in the room, it's amazing. You submit a request online in the system.
You have to provide a justification for what you're going to use. You have to explain the project behind it. You have to explain basically what you expect to get out of it and how you will use those results. And that goes through a review process that can take several months. The formal review process can take anywhere between 6 months up to, I've been told, 18 months. Basically, I can use the supercomputer from anywhere in the world as long as I have a secure connection to it. And then once I'm logged onto it, it's as if I'm there using the supercomputer in the actual building where it's housed. I can upload the code that I need to use to run and any data files that need to go in for inputs. And then I can simply use a command to submit a job on the supercomputer, and it puts it in a long queue of different people who have submitted jobs on the supercomputer.
All I can tell you is there were days that I asked Ryan how things were going, and he said, it's going to be another few days because I have simulations running. So for the paper that we wrote for this particular result, it was about 800,000 hours of computational time.
When I'm actually doing the research and doing the simulations, like I said, I don't think too much about it, but when I talk to other people and explain what I'm doing, that's when I realize, oh, these are really big simulations, and there's a lot of stuff going on here that most people will never see, or the amount of computational resources that most people will never use in their life. So using the supercomputer and getting the simulation data back was a process that just continuously would do it over several months. I would have to run a simulation, download the data, look at it, see if it was doing what I expected it to do. If there was anything that was wrong, I had to go back and figure out what was wrong with the code. Then I would make that change to the code on the supercomputer, run the simulation again, download the data, look at it, and just repeat the process over many, many months, over basically a year.
Fact is, sometimes it can take decades to make things happen, but you have to have the patience, and hopefully that's what most astronomers have, and they need is patience, because the universe doesn't always bend to your will, and you have to wait to find out what's going on.
It was one of those things where I didn't know exactly what would come out of the simulations. That's why we're doing it. And that's sort of the case as it was here. We run the simulations, and then something unexpected came out. Oh, these AGN, these low-power AGNs, actually have a very large impact on their host galaxies. The jets can be split. They can be split by a dense cloud into streams as they come out of the galaxy. They can be deflected, which is they change direction entirely. And in some cases, the jet can be entirely stopped.
Are we seeing star formation that's being created by the jets impacting the clouds, which I think would be really cool, because again, that says the black holes are doing something amazing to the galaxies by being there. Or we could see that the jets could be disrupting the star formation and slowing it down, which is another possibility. And those two things, we don't know yet. Which one is the right answer?
The two major things to draw out of this is just how complex these jets are because they interact with their host galaxy. They're not simple, they're not nice, smooth outflows. The other thing is that these low-power AGN jets, the galaxy determines what the jets look like to a greater degree than has been assumed before.
I never thought I'd be involved in a project that uses supercomputer, so to me it was a bit of an alien thing. And so I was fascinated that we actually were doing this. And yes, when I saw the results that came out, I was impressed, I was excited.
Just a very exciting thing to study, something that is so incredibly new to everybody.
And in that report from NASA TV, we heard from astronomers Ryan Tanner and Kimberly Weaver from the Goddard Space Flight Center in Greenbelt, Maryland. This is SpaceTime. Still to come, Rocket Lab launches NASA's new storm-chasing satellites, and Virgin Galactic to resume flights to the edge of space next week. All that and more still to come on SpaceTime.
A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
Rocket Lab has successfully launched a pair of NASA storm-chasing satellites. The two CubeSats are designed to study tropical cyclones, including hurricanes and typhoons, as part of NASA's time-resolved observations of precipitation structure and storm intensity with a constellation of smallsats, or TROPICS program. They really worked for that acronym, didn't they? NASA's Director of Earth Science Division, Karen St. Germain, says providing more frequent imaging will not only improve situational awareness when a hurricane forms, but the data will provide information for models that help scientists determine how the storm is changing over time in order to improve forecasting. TROPICS is a constellation of 4 identical CubeSats designed to observe tropical cyclones in a unique inclined low Earth orbit over the planet's tropics. This orbit will allow these spacecraft to travel over any given storm about once every hour. That compares well to current weather tracking satellites, which have timings of about once every 6 hours. This report from NASA TV.
Hurricanes are some of the most powerful and destructive weather events on Earth. The 2020 Atlantic hurricane season was brutal, producing a record-breaking 30 named storms. What's more, 10 of those storms were characterized as rapidly intensifying, some throttling up by 100 miles per hour in under 2 days. Many weather satellites will generally measure a storm only once every few hours, leaving gaps in coverage where a storm may quickly strengthen. To help fill this observation gap, NASA is launching TROPICS, a collection of satellites designed to make a big impact on our understanding of damaging storms. Their mission? To provide near-hourly observations of a storm's precipitation, temperature, and humidity, allowing scientists to better understand what drives a storm's intensification. To achieve this, researchers at MIT's Lincoln Laboratory developed a miniaturized microwave radiometer that's about the size of a cup of coffee. This small instrument will measure storm strength by detecting the thermal radiation naturally emitted by the oxygen and water vapor in the air. As Earth's climate continues to change, cost-effective but powerful satellites like TROPICS will be an important tool to help us better observe developments driving rapid changes in powerful storms, and help forecasters better predict and prepare for the weather ahead.
My name is Stuart Cook, and I work for NASA Langley Research Center. My job title is I'm the mission manager for the TROPICS project. Think about 4 satellites orbiting the Earth. These satellites are looking down at clouds, at storms, at hurricanes, and they're looking to see how they form, how they intensify, or how they get stronger. So with TROPICS, we have 4 CubeSats that are going to be orbiting the Earth. They're about the size of a loaf of bread, so very small compared to your traditional satellites. And the beauty of having 4 of these things orbiting the Earth is that they can revisit a storm every hour, which is very different from how traditional satellites do it. They may come by the same storm once every 10 hours. The data from TROPICS, we're going to feed that to our partners, which are like NOAA, the National Hurricane Center. They take it and it helps them improve their hurricane forecasting and hurricane modeling. So when you think about it from the end users and you look at a TV and you say, hey, a hurricane's coming up the coast of Florida, it says the storm could go this direction, it could go this direction. We have improved models that will have a tighter band of where that storm is going to be. It's giving better forecast information to not only NOAA, but to the viewers. So for the first launch is, we're going to have a launch window of maybe 2 hours. It says it can launch between 1 and 3 p.m. New Zealand time. The second launch, there's a lot of synchronization that has to happen, so it's pretty exciting for a company like Rocket Lab to be able to do that with that kind of precision to help us meet our mission goals. During the launch, I'll be in the Mission Control Center here, so that'll be a new experience. I'll be on console to give the roll call for all systems go for the payloads. We're just so excited to really see it happen now. I can't just contain my excitement because it's just a lot of anticipation leading up to this moment.
The rocket-like Hurricane mission was launched aboard an Electron rocket from the company's Mahia Peninsula Launch Complex 1 Pad B on New Zealand's North Island east coast.
All operators, this is the LD on mission proceeding with the go-no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon's go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LD sub.
LD sub is go.
The go-no-go sequence is complete. We are go for terminal count at T-minus 10. From this time, the 3-word hold procedure is in effect. Avionics LD mission.
LD avionics.
Yes, sir. Please proceed with sequence 56, the avionics terminal check sequence.
Sequence 56 in work. S-band is switched to high power for flight. Vehicle is on internal power. AFTS is green and enabled for flight.
Lockset is complete. System is in recirc. Anti-geysering is disabled.
Stage 1, Stage 2, press for flight.
High flow engine purge enabled. Deluge activated. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
HVB discharge is nominal.
Electron is soaring through the sky right now after lifting off from Pad B at Launch Complex 1, now on its way to low Earth orbit for NASA and Tropics. The first launch milestone the rocket will pass through is Max Q, when the forces against Electron are at their peak as the rocket moves quickly through the atmosphere. Mission Control is expected to call that out on the net shortly.
Cleared Max Q.
Great news there with Max Q and onward and upward for Electron. It has only been about a minute since liftoff, and already the rocket is at its speeds of over 2,000 kilometers an hour, a mere fraction of the 27,000 plus kilometers an hour that is orbital velocity, which will reach ahead of payload deployment in the next 30 minutes or so.
Next, though, is the separation of the rocket between stages 1 and 2. For that to happen, we first need the 9 Rutherford engines currently burning hot to shut down, an action called main engine cutoff or MECO. Then a few moments later, stages 1 and 2 will spring apart. We'll hear that called out as stage separation. Then the single space-optimized Rutherford engine on the second stage will light up and carry on with the Tropics mission.
MECO confirm.
Stage separation success.
Stage ignition.
Exactly as we expect, there goes MECO, stage separation. The Rutherford engine nozzle is glowing hot on the second stage. The Tropics satellites remain in good health on the Electron, and soon the rocket's onboard computer will command the fairing to separate and fall away. Now that we're in the vacuum of space, Tropics doesn't need the protection of the fairing anymore, so we get rid of that dead weight to maximize fuel efficiency on the way to orbit.
Fairing separation successful.
Those 2 nose cone halves falling away as planned with the fairing separation. Electron is performing nominally on its way to orbit with a few minutes between now and our next mission milestone, the battery hot swap for our second stage engine at around 6 minutes, 52 seconds into flight.
Guidance is nominal.
Superpropulsion, still nominal.
Electron and Tropics are moving at a good pace right now, well over 8,000 kilometers an hour at the T plus 4 minute mark into the mission. The vehicle is currently at 234 kilometers in altitude, with another 300 or 50 so kilometers to go until we reach our 550 kilometer destination.
Getting there is only one part of the journey, though, as Tropics won't be released immediately at that 550 kilometer first touch. The satellites will remain attached to the rocket's third stage and complete a full loop of Earth before they can be deployed on their home orbit. A quick check of the dials on our screen tell us that all remains nominal for Electron and Tropics. The rocket is moving steadily at more than 9,000 kilometers an hour, and we are inching closer to that 550 kilometer mark.
Guidance is nominal. 200 seconds remaining.
What we call the battery hot swap maneuver is a unique action for our Electron rocket. When the first 2 battery packs supplying power to our electropumps on stage 2 are close to being drained, Electron switches to a fresh battery that will ensure the Rutherford engine lasts the distance to orbit. It's a move our rocket has performed countless times before, but it is a move unique to Electron. Battery hot swap is on its way in just a few moments, so we'll bring up the mission control comms again to listen out for the call.
Throttling down. Hot swap successful. Battery jettison.
Just as it was planned, the Rutherford has switched to its new power source with the battery hot swap and is continuing nominally with the Tropics mission. There are a few minutes left in the engine's burn time before the second stage completes its final actions for the mission, shutting down Rutherford and then separating from the third stage.
HVB discharge holding nominal.
This nominal Rutherford burn marks our 360th engine in space, inching us closer to our 400th engine milestone, expected on our 40th Electron launch. In fact, one of those engines to fly next will be an engine that we have already launched before. We are taking the next major step in evolving Electron into a reusable rocket by launching a pre-flown Rutherford engine on one of our missions later this year. That engine, which flew on our There and Back Again mission in May 2022, has undergone the same extensive testing and acceptance processes as any newly built engine and has performed flawlessly throughout multiple full mission duration engine tests. And we are very excited to see that engine back on the pad soon. But back to Tropics, and that second stage is performing well, and the Tropics payload is healthy as both continue travelling at speeds of over 19,000 kilometres per hour. We are nearly in orbit.
SECO confirm.
There it is from Mission Control, met with a good cheer from our team. SECO and stage separation confirmed. That means our kick stage and Tropic satellites are now in their phasing orbit of Earth. It's been a perfectly nominal mission so far, but Electron's work isn't quite done yet.
That's right, Tropics is a bit different to our usual launches. For this mission, the second stage sending the kick stage directly into a circular orbit, rather than the kick stage taking the satellites on its usual elliptical journey around Earth first. Then, once the kick stage passes the equator at what is called the ascending node, the kick stage's Curie engine lights up to change its inclination to end up in Tropics' desired orbit. The kick stage carrying the Tropics satellites to their 550 kilometre altitude destination as we come up to Curie engine burn for that final inclination change.
Tropics will then be released from their canisterized satellite dispensers, the safety housing made by us for this pair of Tropics smallsats.
Expected nominal Curie ignition.
Word there from Mission Control that the Curie engine is expected to have now ignited. This engine is relightable and it gimbals to orient the kick stage in a very precise manner.
The two 3U CubeSats are each not much bigger than a loaf of bread, and these small but extremely powerful satellites will begin a new constellation in low Earth orbit to monitor tropical cyclones around the world.
Tropics aims to measure temperature, humidity and precipitation so that we can better understand the evolution and structure of storms.
Expected nominal Curie shutdown.
There goes Curie engine shutdown, listening in now for payload deployment.
Expected nominal payload deployment.
When the kick stage passes over the next ground station at Azores, we expect to receive the full telemetry package that confirms everything you've just heard from Mission Control.
A second pair of Tropics CubeSats are planned for launch aboard another Rocket Lab Electron in about 2 weeks, specially timed to insert into the existing constellation. This is SpaceTime. Still to come, Virgin Galactic says it will resume flights to the edge of space next week, with commercial operations to begin next month. And later in the Science Report, new research shows that Australia's black summer bushfires may have triggered our recent triple La Nina event. All that and more still to come on SpaceTime. Virgin Galactic says it will resume flights to the edge of space next week, with commercial operations to begin next month. Next week's flight, known as Unity 25, will be the first mission for the Spaceship Two vehicle in nearly 2 years. It'll carry 4 company employees to over 80 kilometres in altitude, just short of the 100-kilometre high Kármán line, which marks the official start of space. Virgin Galactic says Unity 25 will be the final assessment before full flight operations begin. Unlike most other companies which launch their rockets vertically, Virgin Galactic drop launches its spaceplane from a carrier aircraft that takes off from a conventional runway. The strange-looking 4-engine twin-fuselage White Knight 2 mothership will carry the Spaceship Two winged rocket plane to an altitude of around 50,000 feet. There it'll be released to ignite its rocket engines and quickly accelerate to over Mach 3 as it climbs vertically towards the blackness of space. After soaring to the apogee of its climb, passengers get to experience a few moments of weightlessness and stunning views of the planet beneath that few humans have ever experienced. All too soon, however, the spacecraft begins falling back towards the Earth, eventually gliding to a conventional runway landing. Virgin says its first commercial flight, Galactic 1, will include passengers from the Italian Air Force. Virgin Galactic's space tourism program has suffered a string of delays in recent years, including a fatal accident back in 2014. That was eventually put down to pilot error. The company's already sold over 800 tickets for the 90-minute flights. When they first went on sale, tickets were selling at around $250,000 per seat. However, more recently, the price has gone up to around $500,000. Virgin Galactic's primary competitor in the space tourism business is Blue Origin. It offers vertical launch suborbital flights which go past the Kármán line, thereby allowing their passengers to be classified as true astronauts. and it's already sent 32 people into space aboard its New Shepard rocket from its Texas launch facility. However, the company's rockets have been grounded since last September following the destruction of a New Shepard launch vehicle during an unmanned flight. No word yet as to when they'll be back in the air. This is SpaceTime.
A lifetime of hard work, children laughing in the kitchen, family photos on a restaurant wall, a legacy that lives on. It all comes from the power of a conversation, like the one Tommy Hall had with First Horizon Bank about taking over his father's Charleston-based restaurant business. Now the table is set for a whole new generation. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. First Horizon Bank, member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study shows how smoke emissions from the 2019-2020 Australian Black Summer bushfires enhanced cloud cover over the southern Pacific Ocean, cooling sea surface temperatures and possibly influencing the triple La Nina event, which began in 2020 and continued through to last year. The triple La Nina triggered heavy rains and widespread flooding across much of eastern Australia. The findings, reported in the journal Science Advances, are based on new computer modelling. It highlights the widespread multi-year climate impacts caused by unprecedented wildfire events, including its potential influence on ENSO, the El Niño Southern Oscillation. Australia's 2019-2020 Black Summer bushfires burnt out over 186,000 square kilometres of land, killing more than 3 billion terrestrial vertebrate animals, including many highly endangered species, some of whom were driven to extinction. The massive wildfires destroyed almost 6,000 buildings, including 2,779 homes, and killed at least 34 people. Smoke from the fires spread across the Pacific Ocean, affecting New Zealand, Chile and Argentina. NASA says the fires transported more smoke into the atmosphere than ever previously observed anywhere in the world. By the height of the fires in January 2020, almost 340 million tonnes of carbon dioxide and particulate matter had been emitted into the atmosphere, pervading the stratosphere and completely encircling the entire planet. Two studies led by the Leibniz Institute for Tropical Research found that this increased stratospheric temperatures by up to 2 degrees Celsius for at least 18 months, while at the same time cooling the lower atmosphere close to the Earth's surface. The analysis, reported in the journal Atmospheric Chemistry and Physics, shows that sunlight was dimmed from the subtropics all the way to Antarctica, even more than during the eruption of the volcano Pinatubo back in 1991. The smoke probably also contributed to a record ozone hole over Antarctica in 2020, forming a vortex 1,000 kilometres in diameter which passed over the southern hemisphere for several weeks. Meanwhile, a report in the journal Science found the fires also triggered chemical changes in the stratosphere, including an increase in formaldehyde, chlorine nitrate, chlorine monoxide, and hypochlorous acid, while at the same time causing decreases in ozone, nitrogen dioxide, and hydrochloric acid. Scientists are developing a new citizen science project designed to monitor Australia's bogong moth. Invertebrates Australia is partnering with the Ceres Society for Invertebrate Conservation, Zoos Victoria and Lund University to create a national bogong moth observatory, which will include the development of a citizen scientist bogong watch project. Dr. Kate Umbers has been supported by the Australian Research Council to lead the project, including Bogong Watch, which is modelled after the successful monarch butterfly watch in the United States, and expands on Zoos Victoria's moth tracker to address a major knowledge gap around the distribution and migratory flyways of boggon moths. Well, they've been joking about smell-o-vision for TVs and movies for decades, but now it could become a reality, at least in the world of virtual reality. A report in the journal Nature Communications says tech geeks have created a small wearable virtual reality interface that allows users to smell several different odours, including rosemary, pancake and durian. The device can quickly and accurately generate odours in a localised area and connect wirelessly with virtual reality worlds for what those behind the device claim is an immersive and more realistic user experience. Future research could allow people to detect smells when playing video games, 4D films, and in virtual teaching environments. Okay, now for the most ridiculous story of the week. It seems Connecticut psychic Nancy Milo claims animals choose when and where they're going to die, and some pets choose to become guardian angels in heaven, while others are reincarnated on Earth. Tim Mendham from Australian Skeptics says it seems there are simply no taboos alleged psychics won't cross in order to achieve fame or fortune.
Churches, I believe, say that animals do not go to heaven, okay? So when Fluffy or Spot dies, that's it.
Don't believe them, children. They do go to heaven.
They do go to heaven, obviously, unless they're a bad dog.
No such thing as a bad dog, just bad people.
Bad parents, yeah. So, yes, I mean, it's pretty upsetting to people, you know, when your favourite member of the family sort of passes on to the great unknown, that they don't go anywhere. So it'd be nice to believe if they went to heaven that, you know, when I die, I'm going to be joined again by Fluffy. So various psychics have been picking up on the I speak to animals routine. How you disprove it, I don't know, but whatever. And so one particular one in the US was sort of not only sort of saying that I can speak to animals, but she believes animals choose when and where they're going to die, and that some pets become guardian angels in heaven while others reincarnate on Earth. I don't know how you do that. Apparently you can talk to them and say, what were you previously? I was a lizard. Anyway, she says that each death is a beautifully orchestrated dance of waiting for the humans to be ready, or waiting to pass before the family goes on holidays, which is very convenient, very nice of the animal to die before you go on holidays, so you don't have to pay kennel fees, etc. Some dogs want to pass by their favourite tree or with music on. So she's been able to speak, this person, with the animals from a very young age, and she's learned about the afterlife from speaking to pets who have died. And she says that one of the greatest honours is that she helps animals cross over the Rainbow Bridge, which I think is confusing your myths and your religions a bit. That's Viking, isn't it? Anyway, I'm not a
neighbours have a dog, and I don't think he'd be crossing any Rainbow Bridge when he passes away. He's going straight to Stovacor with the rest of the Klingons.
I have no great belief of sort of pet talkers, people, spirits of psychics. I don't have much belief in psychics talking to people either, actually, for that matter, but talking to animals and suggesting that they choose their own time of death.
Don't know how that explains roadkill and slaughterhouses, however.
Oh dear. There's always a psychic for every situation, and whether they firmly believe it, whether they're off with the fairies themselves, or whether they're out to make some money, and I will talk to your pets and tell them how much Fluffy loves you, it's hard to say.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.